Thank you for attending our lightning talk today. I'm Emily Roberts, and I represent navigation electronics on the GIS mapping side here in Alabama. I'm also the Central Region Director of this association. Today, we're going to talk about an Alabama water utility and their GIS success story. First, I'd like to start by telling you a little more about navigation electronics, also known as NEI. They've been around for about 32 years, and they were one of the first 5 authorized Trimble dealers in the United States. We now cover 6 states, and we provide knowledge and expertise to companies, agencies, and individuals in the survey and mapping communities to customize a GPS, and in my case also GIS workflow that fits their current and future needs. I really believe what sets us apart is that we're a family-owned company, and also the service we provide when we meet you, as well as years into the future. Again, I'm Emily Roberts. I recently celebrated my 1-year anniversary with NEI. Previously, I traveled all over the Southeast for natural gas pipeline companies, so I'm very happy to be back in my home state. Eric Bach is our training and support manager. He's been with NEI for about 15 years and in the industry for 25. He's not on the call today, but I felt it was important to highlight him. Without the excellent training he provides, I wouldn't even be able to share this customer story with you today. Now let's get into our GIS success story featuring the City of New London Water. I first met with Terry, Brandon, and David in August of 2020. Since then, we've gotten to know each other pretty well. Shout out to David for allowing me to metal detect on his farm. Their office is located in Cropwell, which is just outside of Pell City, and that's in St. Clair County, Alabama.
We are New London Water Authority, sewer and fire, but we mainly just prioritize in water distribution.
My name's Terry Brown. I've been with New London Water going on 19 years.
My name is Brandon Lee. I've been with New London Water for a little over a year, around 13 months.
I'm David Wadsworth, and I've been here for just about 16 years now.
We have somewhere around 100 miles of underground pipe that goes throughout our system.
We have approximately 2,200 meters that we supply services to.
From the first conversation I had with the guys, I knew they had many challenges, those being extremely out-of-date maps, no way to navigate to assets, and the database of the asset attributes lived in each of their heads. This being said, I knew we could come up with a solution that worked for them.
Well, one of the challenges that we faced is finding our valves. We have some maps that were made around 1982, a reference guide, but as you can imagine, a lot of things has changed since '82, and so a lot of times we're actually trying to locate the valves to be able to turn the water off.
And myself as a new employee, when I first came on with New London, I had no knowledge of the prior system. You can't actually get your hands on a paper map that's in the office when you're out in the field actively working. Our main way of locating a valve or a meter box or something that has been overgrown or covered up by erosion or leaves was to use either a valve locator or a probe rod, or sometimes even a shovel or a backhoe, to uncover and try to run across it.
Without access to even semi-current maps, it made finding covered assets a lot more labor-intensive took up a lot of their time and resources and could potentially be dangerous. The GPS solution I created allowed them to revolutionize their workflow. Not only could their assets be documented spatially along with pertinent data related to that asset, but they could also navigate back to them at a later date thanks to the mapping grade GPS receiver.
Now we have the ability to get within so many inches and probe and find it. It gets us right, basically right on top of, the object we're looking for, whether it be a meter or a gate valve. And if we have our distribution points in on our main, we can get on top of the main.
The GPS solution I created from our assessment was a Trimble R2 receiver. This receiver allows the user to connect wirelessly to iOS, Android, and Windows devices. The T7 Windows 10 tablet is a great pairing with the R2 because it's made for the field user. Gorilla Glass, sunlight readable screen, and its operating temperature and waterproof specs make it a no-brainer for a tablet solution.
It's going to be able to help us in finding the valves, which, like I say, when we have a blowout, and it's an emergency, we don't want to cut anybody off that we don't have to. So a lot of times in the past, we couldn't find a valve. We had to go to the next valve, and so it cut more people off. With this technology, be able to cut the valve off that needs to be cut off. Less people will be out of service. It will be faster service and easier on the employees and the company itself. Less water wasted, and it's just going to help us out.
NEI has created a training and support package specifically for our rural water clients. This will include 10 hours of training and setup with Eric, as well as our NEI water model for data collection. This training is invaluable for individuals that have little to no experience with GIS.
I had no prior GIS mapping experience.
Through conversations and a site visit, I found that there were portions of the New London water system that were in cellular dead zones. When you don't have access to a cell signal while you're out in the field, you cannot utilize the ALDOT base station network to get your corrections. Therefore, I offered them a solution that will allow them to post-process their data. It's the opposite of real-time correction. You collect out in the field uncorrected, and when you bring it back in the office, that's when you apply the corrections.
With post-processing, it has given us the ability to take points out in the field where we have virtually no cell service, and we can bring that collected data back to the office and use base stations to hone in on the point taken in the system, the distribution system.
The workflow process we've chosen is pretty streamlined. You will be connected to the Trimble Connect cloud through the Trimble Positions plugin within ArcMap Desktop. So basically, you create your project within ArcMap and it pushes it out to the cloud. From there, you'll open up the TerraFlex app on your data collection device and sync it up with the cloud. After that, you're good to go out in the field. So once you get to your job site, connect your Trimble receiver via Bluetooth to your handheld device and open up the TerraFlex app and go ahead and start collecting points. If you are connected to the internet, then the points that you collect will go straight to the Trimble Connect cloud. If not, once you get back to an area with internet connection, then you will hit sync within the TerraFlex app, and that'll go ahead and sync you up with the cloud. Once you get back into the office and you're ready to post-process, you go ahead and open up your project within ArcMap and use that same Trimble Positions plugin to check in your data from the Trimble Connect cloud. Then you can post-process, and it's really simple and walks you through the steps to get you those accurate, corrected locations.
The first time we actually went in the field and used the device, we took some points in a local subdivision, and we were trying it out and learning how the R2 and the T7 worked. And we took a few points, and Eric, he's the one that our instructor that's been walking us through post processing and just teaching us how to basically use the system and input data and upload. He actually helped us go in and edit. You have a preset options basically for a water distribution system, and he went in and helped edit to customize it to our system's needs.
I'm going to give a brief demonstration of what the TerraFlex collection software looks like out in the field. This is a screen mirroring app using a T7 tablet. I've already connected to my R2 receiver and the real-time network here in Alabama. On the top, you'll see real-time, horizontal, and vertical estimated accuracies, and the same on the bottom, but for post-processing. I'm over here by a valve, so I'm going to choose system valve. At the bottom of the screen, you'll see it taking 1 point per second and counting up to 10, and that is a feature of the post-processing workflow. From here, we'll just start filling out our attribute data. I'm going to speed this up. I definitely can't type this quickly, but that would be pretty cool if I could. As you can see, our water model is loaded with all kinds of drop-down menus and yes/no options, and also calendars and even comment fields. These features and their attributes can be tweaked slightly to fit your needs. We'll be taking a picture and adding it as well. Towards the bottom, you'll see fields that are grayed out, and those are the metadata fields that are populated on their own. Once you're finished, you'll just hit save, and if you're connected to the internet, your point will then go to our Trimble Connect cloud automatically. Turn off my background map to make this a little easier to see, but the black dot is me across the street and the green dot is the valve point that I took. Once you click on an existing point, you can actually navigate back to it. There you can see we're 32 feet away from it, and it'll actually give you a compass to get back to it.
Very beneficial. We've been able to take what we've done so far. We were able to go back out there and go back to our same points and get right on them and do our locating that way.
With the software setup and training provided by Eric and the hard work and dedication of New London, they have now mapped parts of their system. They were kind enough to share some data with me. Here you can see an existing neighborhood and then a proposed neighborhood below. By using the Identify tool, you can click on any of the points or lines and see the attribute data for that feature. Since they were able to collect this data while construction was going on and there was an open trench, they will have a very accurate location of that water line.
We had a head operator retire last year, first of last year, and we got another operator that's retiring in the near future. Knowledge just is from the older employees that's been here through the years that they have stored mentally, and with their retirement, we don't have that knowledge anymore. But we can, before they exit, we can take points out in the field for future employees that come in with virtually no knowledge of the system.
I'm gonna say it's a big step as far as paying the money out to begin with. It is a lot of money to pay out at one time, but for the benefit that it's going to be, whether people like me retiring or even the younger people that's coming on to take the points and be able to find the right locations that need to be, whether it's a curb stop, a saddle, a main, a meter, a fire hydrant, a valve, ever what it might be, then it's going to be a great asset to the company and to the employees.
While this setup worked fantastic for New London, it's important to note that we have many different workflow options to fit your needs. Our GPS receivers and handhelds are made to work with Trimble TerraFlex as well as Esri collection softwares like Collector or Field Maps. They also operate with some third-party apps as well. We have another rural water package that's specifically designed to work with Esri collection software. Again, thank you for attending our lightning talk. I also want to give a big thanks to New London. They were such good sports and let me record the interview. Please reach out to me if you have any questions. You can call me at 256-665-5589. I have some parting advice from David for anyone who's considering mapping their system.
Say it, Bo.
You should have started yesterday.